Today we're going to work on solving problems in slope-intercept form. So we've got some that have a constant rate of change or speed and then a beginning amount. So an initial value as we've called it before. So this would be like our initial value. That's a really big, and this would be our rate of change. So if you remember from when we were doing word problems before, we said that m is our rate of change, or how it's going to move. It's also known as the slope. And b is going to be our initial value, also known as our y-intercept. So let's take a look at our first problem here. Way too thick of a pen. So we have an airplane. It's 30,000 feet above the ground. It begins descending at a rate of 2,000 feet per minute. So we have some information here. Assuming the plane continues at the same rate of descent, the plane's height and minutes above the ground are related to each other. So we're going to be beginning at 30,000 feet above the ground. We are descending. Descending means that they're going down 2,000 feet per minute. So we need to define what our variable is going to stand for. I like to make the x-axis always about time. So this is going to be our time in minutes because we are working with minutes here. And y-axis can be the height. And the height is being measured in feet. So we are to fill in the given information from the problem and decide what all is going to apply to this situation. So do we have a y-intercept? We have a beginning height, and that's going to be our 30,000 feet. We have a slope, which is the rate of change. It's descending, so we're going to make this a negative 2,000. We don't really have any points. We're not going to worry about those pieces of information. And we'll go from there. So that's our information at this point. We're asked to, on the first part of this question, we are writing an equation to model the situation. So we said that our m is 30,000, our b, or should I say our b is 30,000, and our m, our rate of change, is negative 2,000. So we're writing this in slope-intercept form, y equals mx plus b. So let's fill in our m and our b and keep y and x. So y is equal to, our rate of change is negative 2,000 times x, plus we're starting at a height of 30,000 feet. It's above ground, so it's going to be a positive height. Now we're going to use the equation to find the altitude of the plane after 5 minutes. So we decided that our y-axis is going to be height, our time is going to be our x-axis. So I'm going to make sure that this time is going to go in for x, because that's equal to our time in minutes. So I'm going to take my equation I just wrote in part A. Y is equal to negative 2,000 x plus 30,000. And I'm going to replace just y and solve for, replace just x and solve for y. So I have negative 2,000 times 5, because we're finding that's going to be our time factor, plus 30,000. And the y is going to tell us how high it's going to be, what's the altitude. So I'm going to go ahead and use my order of operations, PEMDAS. Don't have any parentheses, don't have any exponents. Multiplying and dividing, I'm going to multiply from left to right. Negative 2,000 times 5 is going to be negative 10,000 plus the 30,000. And then I'm going to, now that I've taken care of the multiplying and dividing, I'm going to add and subtract. So y is equal to negative 10,000 plus 30,000. It's the same as 30,000 minus 10,000. So we'll say it's going to be 20,000, and we're measuring our height in feet, which makes it a better answer. When we have our units, including the units is really important when you're working with word problems, because sometimes units, things can be measured in different types of things, like minutes for time, hours for time. You want to be clear on that. So you're going to go ahead and do the second one. Let's take a look at the second one. Here we have a different situation where there's money being saved up. So suppose you received $100 for a graduation present, and you deposit it into a savings account. Then each week thereafter you add $5 to the account, but no interest is earned. The amount in the account is a function of the number of weeks that has passed. So when we say that something is a function of something else, it means that the amount that's in the account depends, depends on the number of weeks that has passed. So we make our independent variable our x and our dependent variable our y. So the part that's independent is the time that's passing, and the time is being measured in weeks. So you could call it number of weeks or time in weeks. Either one of those would work. Y is going to be the amount of money. And I'm just going to make a dollar sign here. Amount of money. So where are we starting? They start off with $100 in the bank from their graduation. They have $100. That's where we begin. That's our y-intercept, $100. And each week, how much are they adding? We're adding $5 per week. So we have a positive slope of 5. We don't really have a first point. We don't really have a second point. We're just going to go ahead and write this equation in slope-intercept form. So part A, we need to write the equation. And it even tells us here in part A, we're looking at y, the amount in y, after x number of weeks. So I said we're beginning B is 100. We're moving M, our rate of change is 5. Or plus 5 would be even better. So writing in y equals mx plus b form. Y is equal to, let's replace m with 5. Keep the x, and then we begin plus b is plus 100. Now part B is asking us to use the equation to find when you will have $300 in the account. So the amount of money we have in the account is our y value. So we're going to take our equation, y equals 5x plus 100, and we're going to replace y with 300. So that's going to go straight into y. So y is now going to be replaced with $310. 310 equals 5x plus 100. To solve this, we want to get our variable on one side, everything else on the other. So we have 5x is what we're solving for. We're going to use our order of operations backwards, PEMDAS backwards. So we want to get our variable term by itself by working backwards from there. So we need to undo any adding or subtracting. We have plus 100, so we're going to subtract 100 on both sides. Plus 100 minus 100 is going to give me 0. 310 minus 100 is 210, is equal to 5x. We've taken care of our adding, subtracting. Now we need to undo some multiplying and dividing. 5x is the same as 5 times x. So I'm going to get rid of the 5 by dividing by 5 on both sides. And x is equal to 210 divided by 5. 5 does not go into 2. 5 goes into 21 4 times. 5 times 4 is 20. Take away, we have 1. We bring down our 0. 5 goes into 10 2 times, leaving us a remainder of 0. So x is going to equal 42. And if we want to make this a better answer, we're going to say 42 weeks till they hit $310. And that's how you're going to do the ones with the slope-intercept form. You're going to work on practicing these problems we're going to practice them in IXL. You're going to work in level K, assignment S10, and that's working with word problems using slope-intercept form. Going to work on this today, Tuesday, and Wednesday. If you finish up with this assignment right here, then I want you to work in your recommendations from your diagnostics. So go to the diagnostic tab, find your lowest scores, and work on those recommendations, okay? And that's how you're going to work on this.